Hi, welcome to our chapter 5. We're going to begin today talking about some trig identities, and we've already learned a little bit about some of the basic trig identities, which will refresh your memory on those in a few minutes. But today we're going to be using what we already know to prove whether or not some equation that has trig expressions is an identity. To be an identity, it has to be able to work for any value of the variable. So if we're going to do that, we have to show algebraically that one side is identical to the other. Show algebraically that one side of an equation is equivalent to the other side. That is, has the same value, equivalent to the other side. One of the drawbacks is you can't assume that the equal sign belongs there. You're trying to show that an equal sign does belong in between those two pieces. So you can't assume the equal sign is there. That is, you can't work across the equal sign, but you're trying to show that the equal sign belongs in this equation. All right. To help us get going today, I have a list of some tips that I'd like to have you copy down that will help you as you're trying to verify whether or not an equation is an identity. So here come a list of tips. First, try transforming the more complicated looking side into the simpler side. Folks, it's harder to make the simple look hard. It's easier to simplify. So we want to start with what we think is the more complicated side in general and try and change that into the simpler side. A second tip: substitute basic identities wherever it's possible. Folks, we'll remind you of those identities, but remembering things like the cosecant is the reciprocal of the sine, or that tangent is the same thing as sine divided by cosine. If we can substitute basic identities wherever possible, that'll make our job easier. A third tip: remember that about factoring or multiplying. So it may be possible for us to factor expressions, trig expressions, using the same techniques that we would factor other quadratics, or multiply, of course. It's always to our benefit to remember to multiply, or it's okay to multiply by a convenient form of 1, such as if I am looking at sine over cosine, I could multiply both top and bottom by cosine and have sine cosine over cosine squared. Multiplying by a convenient form of 1 sometimes will help us simplify an expression. We should, and this is one of my favorite, express trig functions in terms of sine and cosine. Those are the two basic building blocks. Everything else, every other trig expression can be written in terms of sine and cosine. And sometimes that's our best bet when we're trying to verify identities. Lastly, it's possible to combine fractions by adding or subtracting, that is, finding a common denominator and putting both over. So you can see that we're going to be using lots of algebra strategies as we try and verify these trig identities. We said that we'd remind you of some of the identities that we've learned previously. So I'm going to ask you to just make a list, and I believe there's a spot in your notes to do this. I would remind you of the Pythagorean identities. There are 3. Sine squared of x plus cosine squared of x is equal to 1. That's the biggie. So if we see an expression that has sine squared plus cosine squared, folks, we can substitute a 1 in place of that, and that's going to be important for us. The other 2 Pythagorean identities come from dividing through by either sine squared or cosine squared. They can be generated. What I would ask you to ask you to think about when you see an expression that has a cotangent squared. Just keep that in the back of your mind. Hey, that's one of those Pythagorean things. Same thing for tangent squared and secant squared. The quotient identities involve the tangent and the cotangent. Tangent of any angle is the same thing as its sine divided by its cosine. The cotangent is the reciprocal, so it's the upside down of that. I would remind you of the other reciprocal identities. That sine and cosecant are reciprocals of each other. Cosine and secant, tangent and cotangent. And lastly, I'd ask you to just remember, keep in your mind those factoring patterns that we've used all through high school. The difference of two squares, the difference of two cubes, which is newer for us, and what happens, this is a multiplying pattern, it's not a factoring pattern, but a multiplying pattern. When you square a binomial, you get that perfect square trinomial, it's called. So those things will serve us well as we're looking at verifying identities. And we're going to kind of begin right in. We're going to throw you under the bus, as it were. We want to verify that cosine of x is the same thing as cotangent of x divided by cosecant of x. I would ask you to remember that you are not allowed to work across the equal sign. In fact, when I'm doing this, I put a bar just to remind myself I can't cross over from one side to the other. One of our tips said that you should take the more complicated side and try and transform it into the simpler. This looks more complicated, and I want to try to start here. A second of our tips said, remember that we can write things in terms of sine and cosine, and that's almost always a good idea. Cotangent, for example, which is on top here, is the same thing as the cosine of an angle divided by its sine. This is part of a fraction where the bottom half is the cosecant, and the cosecant is the reciprocal of the sine. So we could write the bottom of that fraction, its denominator, this way, 1 over sine x. And I know right now you're thinking, hey, look at that, the denominators are the same. I remember from before that means things are going to cancel for sure. The proper math is multiply top and bottom by the reciprocal of the bottom. So we're multiplying top and bottom by the reciprocal of what was in the bottom. This is canceled. And look at that, we've got sine x's that cancel out. Friends, I think we're where we want to be. We want to be able to say that the right side of this is exactly identical to the left side. And notice we only worked on the one side here. So the equal sign is justified. A lot of times I'm going to do that just to say, yep, I got where I was supposed to get. Good. You verified your very first trig identity, folks. You took that equation and showed that the equal sign really does belong there. Our next one is a little bit more complicated. I'm going to go ahead though and draw my bar because I want to remind myself. This is not a place where you can do the same thing to both sides. You do not know that that equal sign belongs there. Really, a question mark is what belongs there. We want to be able to show that they're equal. Now, I said that we can't work across the equal sign. However, we can do some work on both sides of the equal sign, and that might be a good idea in this one. I see that we have a quantity that needs to be squared here. So let's go ahead and do the math for that. Now, if you're a box method person, you're going to draw the box, and you're going to think we're doing sine of an angle minus the cosine of an angle by itself. Okay, sine minus cosine. And go ahead and do your box method. If you're a foiler, well, it all works out the same way. We're going to end up with a sine squared of a. So I'm going to go ahead and write that. Sine squared a. This is going to have some guts. Sine a times cosine a twice, and it's negative. So minus 2, and I'm just looking here, sine a cosine a. And then the bottom right would be negative cosine times negative cosine. That's cosine squared positive. So plus cosine squared A. And yeah, that's really hard to fit all that in that little spot. I'm happy though, because you see what I'm noticing right there is a sine squared A plus a cosine squared A. You guys, that's the Pythagorean identity. We can replace that with a 1. So let's simplify this side to say this. 1 minus 2 sine A cosine A. And I don't think we can do anything more here. We're in already the basics of sine and cosine. This is not one of our identities, so I think it's time for us to maybe look at the other side of this and see if we can simplify a little over here. I see the 1, which I like. Minus 2 sine squared A times a cotangent. You know what, I'm going to just flip that over 1 because I know we can, anything can be turned into a fraction that way. Cotangent is the same thing as cosine A over sine A. And I would ask you to think about this, folks. We've got a multiplication here, and a sign on the bottom here will knock out a sign there. I want you to think about that real quickly, okay? 1 power of sine on the bottom knocks out 1 power of sine on the top. And when we simplify, this is what we have. 1 minus 2 sine A, there's only 1 power of it there, times cosine of A. And I think to myself, well, geez, those are exactly the same, you guys. We've done it. We've said now that the equal sign is justified. This side and this are identical. Okay, we verified that identity. Very good. It's kind of like a little puzzle, and I like puzzles. All right, we're going to do a different application, same kind of work, only this time our job is to find a numeric value for a trig function. When we're finished here, we should be able to say, tangent equals number, or sine equals number. We are not verifying identities anymore, so it is okay for us to work across the equal sign, and I'm sure that we will at some point or another. Some of the same rules, though, apply. The tangent, well, I'd be a lot happier if I wrote that as sine of x over cosine x. Okay? Getting back and putting things in terms of sine and cosine is very often a good idea. On the other side, 1/4 times, well, secant is the reciprocal of cosine. So 1 over cosine x. Hey, I'm kind of liking that. If I multiplied both sides by cosine, I would end up, I think, having, yeah, I think that's where we want to go. We're going to multiply both sides by cosine. See, we're just doing algebra, folks. It's just some algebra. Cosine of x on both sides. That cancels, and we're right where we want to be. Trig function equals number. The sine of x is equal to 1/4. Very good. Well, this one looks a little bit more ambitious, but it's got some of the same flavor. I see cotangent on both sides. Well, let's investigate. Suppose we divide through by that cotangent right off the bat. Let's divide everywhere by the cotangent of x and see what happens. Now, here, that's 1. And I have an inkling that I may want to represent that cotangent right there as a fraction, cosine over sine. So I'm going to just say I recognize that sine x can be turned into a fraction, and now I fraction divided by fraction. That would be equal on this side, while the cotangents knock each other out. Negative cosine x. All right, let's see. Well, if I simplify this, that may bring something to mind. So let's multiply top and bottom on this fraction by the reciprocal of its bottom. That is, we're going to multiply top and bottom here by sine over cosine. I have to really be careful. I forget my x's all the time. Sine over cosine. And let's see what shakes out of that. 1 plus, well, this is all gone. And we have a sine squared over cosine equals the negative cosine of x. Alright, I really am not a fan of fractions, and so I think that what I would like to do next here is multiply by cosine x. Each term will have to be multiplied by it, so cosine x times 1 is cosine x. Here, if I multiply sine squared over cosine by cosine, I'm going to get plus sine squared. That is, the denominator goes away in that fraction. I multiply over here by cosine, because I have to do it everywhere. I'm going to get a negative cosine squared x. And I'm thinking I like this, folks. I want to tell you why. I see a possibility to get sine squared plus cosine squared. And I know that's a number. So I'm going to do that, actually. I'm going to subtract this cosine x, and I'm going to add that cosine squared x. So I'm going to end up over here with a sine squared x plus cosine squared x. And we're adding a cosine squared x to both sides. On this side, I'm going to subtract a cosine x, so I get a, see that? Sine squared plus cosine squared, that's 1. 1 is the same thing as the negative cosine of x. That must mean that negative 1 is the cosine of x. And I have got trig function equals number. That one was a little bit more involved, and I'll bet you that if you think about it, you could maybe find an easier way to get to that same result. Okay? Challenge yourself and see if you can't do that. Okay, that brings us to the end of this lesson. We're going to have lots of chances to verify trig identities and to do a little bit of algebra with trig functions in class tomorrow. Please get out there and try that. You could try. Have a good night.